Good day, viewers. Welcome to Chemistry WAEC 2024. Today we are dealing on salt analysis reports for Chemistry WAEC 2024. Now, in salt analysis for Chemistry WAEC 2024, we're given sample C is a mixture of sodium triisocarbonate 4 and lead 2-triisonitrate 5. You can call it sodium carbonate and lead nitrate. Now, these two salts are soluble salts. The sodium carbonate is soluble because all sorts of sodium is soluble, and the lead nitrate is soluble because all sorts of nitrate is also soluble. Now, we will be asked to dissolve this mixture of two salts in water, and when you look at these salts, since they are soluble, they will react in water by a reaction called precipitation reaction or double decomposition reaction. Now, when you look at the reaction, when Na2CO3 mixed with solution mixed with PbNO3 bracket 2, what you have will be a precipitate and a soluble salt. Now, the products will be PbCO3 precipitate plus NaNO3 aqueous. Then we must balance. Alright, nitrogen is 2, oxygen is 3, plus 2 here, 9. Sodium is 2 here. Let me quickly put 2 here. And I think the equation is balanced. Sodium is 2 here. The other side is 2. Oxygen is 3 plus 6, which is 9. This is 2 times 3, 6 plus 3, which is 9. Then carbon is 1 there. Over there is 1. Lead is 1. Over there is 1. Now, when we mix these two soluble salts in water, a precipitation reaction will take place. And when that happens, we will be asked to filter off the precipitate. And when you filter out the precipitate, you will have a filtrate, a colorless filtrate, and a white residue. This precipitate will come out, will be tracked on the filter paper as white residue. While this will pass through the pores of the filter paper as colorless filtrate. So that will be our filtrate. Now let's start. Now this is our sample C. The two salts are mixed together already in this, so it's white in color, as you can see. So I use my spatula to scoop it into the beaker. So of course you'll be asked to dissolve it in 10 cm³ of water. You use the measuring cylinder, but I will assume, all right, either 10 cm³ or 5 cm³. I will assume my 10 or 5 cm³. You shake or you stir. So I'm stirring. Why you're stirring is to ensure reaction. So as you can see, this is a white precipitate mixed with the soluble salt. The white precipitate will be lead carbonate and the soluble salt will be sodium nitrate. Then I will filter. This is my filter paper which does the filtration. I'll fold it into 180, then fold it into a cone shape. I'll actually pour water on the body to enable it adhere on the funnel. This is my filter funnel.
Show the inside of it.
So this is how it adheres to the filter paper, okay? So I'm filtering now. I'll pour my solution into it and filter. So it's filtering. You're getting a colorless filtrate. At the end of the day, you will get a white residue. So let me give my reports. Now, this is not two inorganic salts where one is soluble and where the other is insoluble. The both salts are soluble. So it will be wrong for you to write under observation that C partially dissolves, to give the colorless filtrate and the white residue. And you now come here and say C is a mixture of soluble and insoluble salts. No. The observation you will give here is that the mixture of C reacts, all right, the two salts reacts to give a white precipitate, all right. Then your observation will be that the C is a mixture of two soluble salts, and the reaction is a precipitation reaction or a double decomposition reaction. So my observation will be the two salts reacts the water to give a precipitate. All right. Then my observation is this: C is a mixture of two soluble salts. Is that got it? Then, upon filtration, I will have a colorless filtrate and a white residue. So you now say, on filtration, we have semicolon colorless filtrate and white residue. So you come to the inference, the reaction is a precipitation. Is a precipitation reaction, or you say double decomposition reaction. So that is done. Now you may also be asked to give to test your filtrate with litmus papers. Now this is how the filtrates look like. Let me open it. You can see white residue. All right. Then you can see our filtrate, colorless filtrate. Please ensure you report your observation and inference this way. Now let's test the filtrate. This is my blue litmus paper, and this is my red litmus paper. All right. So I test. No reaction. No reaction.
Okay, go ahead.
No reaction. All right. So no action, no reaction on blue and red litmus paper. So you now say filtrate is neutral, not solution. Filtrate is neutral. Filtrate is neutral. Now, I'm not too sure if they will ask this, but in case if they ask, no problem. Now, remember that the filtrate is NaNO2. Of course, it's going to be neutral because when you dissolve this compound in water, all right, what you have will be NaNOH and HNO2, because the water would associate into OH minus and H plus. The OH minus will combine with the sodium there to give you sodium hydroxide, and the H plus will combine with the acidic anion here to give you HNO2. So we see that sodium hydroxide is a strong base, a strong alkali, and HNO2 is a strong acid. So there will be action on either blue and red litmus papers. Now let's quickly go on to our second experiment. You will be asked to perform what I call brown ring test. Yes, brown ring test. Now, in the brown ring test, you have to take some few centimeter cube of the filtrate, like 2 centimeter cube of the filtrate, plus 3 cm cube of freshly prepared FeSO4 solution. That is iron 236 solution. And you add 3 or 2 cm cube of concentrated H2SO4 solution slowly down the side of the test tube. Slowly down the side of the test tube. This is actually my iron 3 that's overstayed. I don't know if it is still active, but we'll test it. This is my freshly prepared iron 2. Just dissolve it in water. I have my concentrated H2SO4 acid. All right. Now let me get some of my filtrates. Brown ring test is a test used to identify 295 ion in the lab. It's a test used to identify 295 ion in the lab. I have to rinse this to avoid precipitation of other sorts. I have to rinse it with still water. So I have okay. Okay. Now let me add freshly prepared iron 2. It's supposed to give me green. It's not giving me green. It's not giving me my results. You see the brown test at the junction of the two aqueous layers, aqueous solutions. The acid is very hot. There's a thermic reaction. I think I'm getting a brownie test. You can see it. The brownie test at the junction of the two layers. Just it. So this is the brownie test.
Okay.
The solution was down here. So here, the acid. That's the brownie test. Alright. Now when you get a new iron 2 sulfate and you prepare a solution, it won't give you don't waste time to give a brown ring test, but this is my brown ring test, okay? All right, thank you. Then you now report a brown ring is formed at the junction of the two aqueous layers. Then your inference will be NO3 minus ion is present. Why the brown ring is formed in June today? The brown ring is formed due to the formation of FeSO4.NO. That is what is responsible for the brown ring formation. Now, another way question could be asked is to the filtrate, add come H2SO4 to the filtrate and heat. When you heat, reddish brown fumes will be involved. Now, your inference will be NO2, the gas will be NO2 from NO3 minus ions. Now, let's go quickly to the residue. Now, the residue, I am suggesting that the residue will be, they will ask you to add HNO3 solution to the residue. Now, I do not take HCl aqueous or H2SO4 aqueous because when you use, this is the residue PbCO3, when you use HCl, there's the formation of PbCl2, all right, which is insoluble, white precipitate. When you use H2SO4, all right, H2SO4, there will be formation of PbSO4 precipitate, all right, which is insoluble, all right. Now, they will ask us to use HNO3 aqueous that will dissolve the residue to a colorless solution. That will dissolve the residue to a colorless solution. All right, when that happens, effervescence will occur. All right, I use my spatula to scoop reasonable amounts of the residue into the larger test tube. All right, now this is my HNO3. The essence of using this is that to dissolve the residue, effervescence would occur. Although H2SO4 and HCl, effervescence will occur, but using it will form a precipitate. So I suggest WAEC will go the way of HNO3. So let me add my aqueous HNO3 acid. Wow. 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 Can dissolve to a colorless solution. Effervescence occur, still occurring. Wow. Beautiful. Beautiful. Beautiful to a colorless solution. Beautiful. All right, let's take down our condition. Our condition will be effervescence occurred then a colorless and odorless gas involved. Comma, we have to confirm the gas. So you say which turns blue, litmus, red, turns an acidic gas. Another way to confirm the gas is, or you say which turns right? Lime water. Okay. Wow, these are reports. We've done lime water level. Now let's go to our first inference. Now your inference will be simple. The gas is CO2 from CO3 2 minus. Please don't only say from this. If you say from this, they won't score you. They will assume maybe perhaps a teacher must have told you the carbonate. So you will say or HCO3 minus. So CO2 can come from either triose with carbonate 4 ions or hydrogen triose with carbonate 4 ions. Alright? So that is our report. Now they will ask you to the resulting mixture. This is a resulting mixture. It's colorless solution. So the resulting solution, add sodium hydroxide in drops. Now when you're adding in drops, you will give your report in drops. When you add in excess, you also give your report in excess. As you give your report in drops and excess, also write your inferences. Now this is sodium hydroxide. Let me add in drops. Remember, this is colorless. Can you see? It's colorless. Now I add in drop. Wow. White precipitate. You can call it chalky. White chalky precipitate. Or white precipitate. Then let me add SS. Wow. It dissolves. The white chalky precipitates are dissolved. Wow. Wonderful. So let's come down here. Your report will be white precipitate. Or you might say chalky in bracket. Alright. Formed in drops. You come over here, calcium ion or ion, like 2 ion present. Never you say aluminum ion is presented. I have seen so many online chemistry teachers adding aluminum ion presented. No, aluminum ion is white gelatinous precipitate. So these two cations could be present. Then in excess, the white precipitate dissolves. In excess. So lead 2 ion present. Now I don't think they will ask you for ammonia, but if they do ask you for ammonia, in drops of ammonia, it will also form white precipitate. Alright, and in excess, the white precipitate will remain insoluble. Alright, so it is when it was in few drops, the white precipitate is lead ion, like 2 ion. When it is excess, the white precipitate is very insoluble, it is still like 2 ion. So I don't think they may ask that aspect. Now, another aspect I'm suspecting they will ask is dissolving the white, the resulting solution. All right, adding ACl. I'm rinsing it. Adding ACl, and then you warm, and then you warm. Now this is my resulting solution from BI. Now let me add it to another test tube. As you can see, all right. Now this is my hydrochloric acid solution. All right. Now let me add it. Wow. White precipitate. Can you see it? White precipitate. Wow, white precipitate. Now, this is possible because of the formation of lead chloride. Lead chloride will give white precipitate with lead nitrate. Lead nitrate. Let me show you on the top. Lead nitrate. Lead nitrate. Let me go by that. Yes, you change with lead nitrate. Now, when you bring sodium nitrate, all right, this is our filtrate plus ACl. You will have it on actually lead. Lead nitrate, sorry. So you have PbCl2 plus HNO2. And this is a white precipitate that was formed in the test. So as you can see, can we balance? This is 2. Just look to here. This is aqueous. This is aqueous. So to give us the precipitate and aqueous. So there is something remarkable about lead chloride. On heating, it will form, or they will ask you to heat. On heating, the white precipitate will be soluble, will dissolve. On cooling, it will what? Reappear. So let's see what happens on warming if the white precipitate will dissolve on warming. Dissolving. Oh, that dissolved. Can you see? That dissolved. Wow. That dissolved. Wow. 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 I love this. When I added hydrochloric acid to the resulting mixture from BI, this is what I got. The white precipitate that was formed, which is lead chloride solid, has been dissolved on warming. Just watch it. It has been dissolved on warming. Now on cooling, it will reappear. We'll see. On cooling, will reappear. It's not magic, it's science. Now let's take down our reports. White precipitate formed, which dissolves on warming and reappears on cooling. Now this is how I want to take my inference. My inference will be the precipitate is PbCl2. You wouldn't know what they actually expecting be. So you may add this or Pb2 plus present. Chemistry students all over the world, this is my expected chemistry practical question 2024 also analysis. Now we don't know, we cannot actually predict them 100% although, but bear in mind that this salt is stable on heating, while this salt will decompose on heating. They might ask you to heat C. Now this will not react, it's stable on heating. Sodium carbonate is stable on heating, but this will react to give you lead oxide plus nitrogen oxide and oxygen on heating. Now when that happens, your observation will be reddish brown fumes involved. reddish brown fumes evolved. Alright? Then you now say, leaving behind a residue which is yellow when hot, or which is red when cool. Yellow when hot, red when cool. Lead 2 oxide is red, naturally red. So when you heat it, it is yellow when cool. Then on your in your heat press, you write the brown gas is NO2 from NO3 minus, and the residue is PBO. Let me conclude by confirming lead for you. You may be asked to add acidified K2CrO2O7. Acidified K2CrO2O7. Alright, to the resulting mixture from BI. So when that happens, you will have a yellow precipitate. I've run it. A yellow precipitate. As you can see, a yellow precipitate is formed. This confirms lead in the lab. So K2CrO2O7 is used for confirmation of lead in the lab. This is our yellow precipitate. You love it and you kiss it. Chemistry made easy. Alright, don't forget our lead 2. The precipitates has reappear again on cooling.
Okay.
See you. I wish you success in your exam. Bye-bye.